let's say we have a kind of a U-Tube filled with some liquid. Liquid is non-viscous, so that the liquid friction is equal to 0. There is no viscosity, so that oscillations, they are not damped. The height over here, that is h, we can neglect this length or we can take it as L also, that doesn't matter. So this is height of the liquid, over here is h. Similarly over here also this h, both the limbs, they are vertical. So now we push some air through this. As a result, this is depressed, this side is depressed, and when we release it, this may be oscillating like this. We intend to find out if this is SHM, this motion is going to be simple harmonic motion or not, and if it is going to be SHM, what is the time period. So as usual, what we do is, first thing is we are going to depress it from here to here. Let's say, but before that, let's say the total mass is m. It is like kind of a flexible rod. It's a flexible rod kind of a thing which has been inserted into this, and it can freely move over here. This is a liquid, right? We can also say the total length of this flexible, very flexible rod, the total length is h here and L here. So it is going to be, total length is going to be h plus L, that is 2h plus L. If the total mass is m, so mass per unit length is going to total mass upon total length, 2h plus L, right? You may come across in some of the books where L is equal to 0, but if you take L, you can get to the result, and then finally if you put the L is equal to 0, you will get the normal result, that is when L is equal to 0, and you can find the answer for that situation also. So mass per unit length is total mass upon total length, that is m upon 2h plus L. Now what we do is, we slightly depress it by distance x. When this goes down by distance x, this will rise by distance x. So as a result, the separation between these two levels is going to 2x. This has gone down x, from this it has gone up by x, so it is now the distance between the two levels. This is going to be 2x. We know that is liquid seeks its own level. If I remove this 2x length, there will not be any oscillation. This length, this level and this level, that is same, there will not be any oscillation. But this 2x length, which we over here, this 2x length and its weight is, which is earth is pulling it this way, this weight is responsible for accelerating the whole mass. So acceleration is being produced by the weight of this section of liquid. If we remove this liquid that is of 2x length, both the sides, the earth is pulling both the sides with the same force, as it is, there will not be any oscillations. But because over here the 2x length is extra and earth is going to pull it by its weight, that is mg, because of this weight, the whole mass, capital mass, this will be accelerating. So mass per unit length we have found it. If we wish to find out what is the mass of this 2x, so mass of length 2x, let's find that mass. So it is going to be m upon 2h plus L into 2x. So this is going to be mass of this. What its weight? Weight is equal to, we know that is m into g, that is m upon 2h plus L into 2x into g, that is the weight. And this weight is responsible for accelerating the whole mass, is equal to total mass. It is responsible for accelerating the whole mass, is equal to m into a. So from here we can say that is m into a, if we write it over here, so m upon 2h plus L, m upon 2h plus L into 2x into g. M and m, they get cancelled, so a comes out to be 2 upon 2h plus L into g into x. Is it constant? Constant, constant, constant. H is constant, h is this length. Don't say it has varied. It has varied, but this h over here is the numerical value of this height. So 2h plus this L, constant, 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 g is constant. So over here we say acceleration proportional to x. Either you displace by distance x or displace by distance y, that doesn't matter. The approach remains the same. Now coming to whether this is opposite directed or not. What we see over here, when we compress it by a distance x or y, displacement is in this direction. Now the restoring force will try to push back to its original position, that is to the same level. Similarly, from here it has gone over here, displacement is in this direction and restoring force is in this direction, acceleration is in this direction. That is, acceleration and displacement, they are opposite directed, so we can very safely say it like this. If this is the condition, acceleration proportional minus displacement, so this means this is SHM. So T is equal to, now we can say T is equal to 2 pi under root x by a, same thing, 2 pi y by a or x by a. So this comes out to 2 pi. If we say x by a, we can put it over here and we can get the answer. So in case it is asked, that is, you can ignore this length. So then put it L is equal to 0 and you can get the answer. Generally in the books, this L is taken as 0, that is U-Tube with this length almost equal to 0. So over there, it takes a form that is A is equal to 2h plus L becomes equal to 0 into G into x. 2 and 2 get cancelled. So A comes out to be G by h into x. So T is equal to 2 pi under root x by A. It comes out to 2 pi x by A. X by A is h by G. So if L is equal to 0, then this is the time period. T is equal to 2 pi under root h by G. This is SHM. These oscillations, they are going to be SHM, whose time period is T is equal to 2 pi under root h by G.